In this lesson, we're looking at the general solutions of cosine, sine, and tangent functions. So let's start with the cosine general solution. So let's say I want to find out the value of x of a given cosine function. So let's say x, so this is the general equation. So 2n pi plus or minus cos inverse a and that of sine where a, both for cosine and sine, for a is an element of -1 to 1, and the n for both sine and cosine, the n is an integer value. So that is as a result of the unit circle, and we know that for cosine and sine functions, the highest value you can get is 1 in the unit circle, and the smallest value you could get, or the minimum value you could get, is -1, and that's why it's the case. For tangent function, if we draw our unit circle, so let's try with the cosine now. So we know that cosine is positive in the first quadrant and the fourth, different color. So 2n pi plus cos inverse a is in the first quadrant, and 2n pi minus cos inverse a is in the fourth quadrant. Whereby for the sine function, it's positive in they're all positive in the first quadrant, but sine is positive. It is also positive in the second quadrant as well. So that means 2n pi plus sine inverse a is in the first quadrant. So the 2n pi is exactly the same as it is for the cosine, the sine function, but the only difference is the negative. So that means 2n plus 1 pi minus sine inverse a will be in the second quadrant. With the tangent function, it's positive in the first quadrant and also positive in the third quadrant. So that means n pi tan inverse will be in there as well. So n pi plus tan inverse will be in the first quadrant as well. Alright, let's have a look at where a is an element of a real number and n is an integer solution. So n can only be an integer solution. So let's have a look at example based on this concept. So we want to find out the general solution of cosine square root 3 on 2. So that means a equals to 2n pi plus or minus. So we get two solutions. Cos inverse square root 3 on 2. So square root 3 on 2 is pi on 6. So 2n where n is an element of an integer, so n is a, so now n can be any number. So let's say n has been restricted. Let's say this solution has been restricted domain, so it has got a restricted domain. So let's say from 0 to 2 pi. So my n value will be 0, 1. So if I multiply here 0, so that means it's going to be pi on 6, which is one solution. And I also do the same thing here, multiply by 2. So that gives me, with a negative there, 11 pi. So if I say n is actually 1, and I say, you know, that in the unit circle, so let's say that one there, the positive, to n pi minus plus, I should say, plus cos inverse a is in the first quadrant, and 2n pi minus cos inverse a is in the fourth quadrant. So if I say n equals to 0, which is going to be the first quadrant, so in this case here, if that's 0, so it's going to be pi on 6. If that's 1, so that's going to be, you know, so 2n pi on 6. And if that's 1, that's going to be 12. 12 minus 1 is actually 11. If n is 1, so that gives me 11 pi on 6, which is on the fourth quadrant. Alright, let's have a look at another example. This time we're just going to have, we're going to check and have a look at another example that's based on a sine function. So this is a sine. So I'm just going to put a coefficient at the front. So that's what I have there. So I'm going to get rid of the coefficient first, and the second thing is, oh yeah, I want to get the general solution for the x value. Or it's going to be 2n plus 1 pi on pi minus sine inverse square root 3, square root 2 I should say, square root 2 on 2. So that's my general solution. So square root 2 on 2 sine inverse is a quarter pi. So that gives me x equals to 2n pi plus quarter pi, or 2n plus 1 pi minus pi on 4, where n is an integer solution. And if that's restricted, so we just substitute back into what has been given to us. So let's have a look at another example, this time with a coefficient. So we can just do it in one go there. So that's going to be cos inverse. I just left the cos inverse there. That's supposed to be cos inverse. Square root 3 on 2, that's better. And the square root pi on, square root 3 on 2 is pi on 6. So divide both sides by 3. And just to make it that one denominator, where n is an element of z integer. And you could, well, if that's restricted domain, so you can just substitute back into whatever is given, and that's going to give you a general solution. So one last example that's based on tangent function this time. So tan inverse square root 3 is pi on 3 based on the unit circle. So this one here is just going to be pi on 3. And divide both sides by 4. So you can just make it one denominator as well too. That's the general solution for, well, tangent is not actually there in the unit circle, but sine and cosine are actually there in the unit circle. You can, so long as you know 2, so you can just work it out by using the ratio. You can just use the ratio, so we know that tan is of cosine, and we can work it out what the tan should be. Alright, that's it for the general solution. So our next lesson will be based on the trigonometric identity using cosine and sine.